Okay, so that's how the new 10980XE looks like in the socket. So that's pretty much how it looks like when I just lapped it quite quickly. The mark on the center is just a fingerprint. But anyway, so it's really hard to get the corners fixed because they are really much lower compared to the center. So, and I also checked, comparing to the retention bracket over here, it will be very hard to get the IHS completely flat because the corners are already so low that if I used like really rough sandpaper to get the whole IHS really flat and then fine tune it, there's already a real risk that the IHS becomes lower than the retention bracket, and then the cooling solution wouldn't make a proper contact with the CPU anymore. So I have to be really careful, but I think it should be okay. Here's the previous or older 9980XE, which did like 5.85 W prime, at least the same for Geekbench3 and GPU Pi, and it's even worse than this one over here. So I think it will be okay. I will give the 10980XE a try now on water, see how it looks like, and then I might try the IHS briefly on rougher sandpapers to get it a little bit more even, but I think it will be okay because most of the heat will come from the center anyways. So the impact of the corners is very minimal in the overall heat transfer anyways. But yeah, so let's get this board mounted on the test bench and let's see how it performs and overclocks. Alright, so this is the first screen we see when we enter the BIOS. So this is the special extreme overclocking BIOS for the Cascade Lake X CPUs with the old microcodes and so on. So this does not have the like the Spectre and Meltdown security patches because they reduce performance at least some bit. So we don't want them for like overclocking purposes, and well, I'm not expecting that I will encounter any of those security issues, so I don't need them for my use now. But so yeah, so I haven't tested this at all, so this is pretty much the first boot, so we can test it together pretty much. So I will use my old profile. It should be saved somewhere around here. 10980XE water. So 4 sticks of AOPCB Samsung B die, same sticks as always. 3800. I think it should work. I should have the memory limit in the operating system. I will use a bit easier timings this time, so 12, 11, 11 instead of 12, 11 and 10. Same sub timings and so on. And let's try 49. Let's try 49. 34 on the mesh. I think it should do that. 1.9 input, 1.24 Vcore. Mesh can be 1.35 because it doesn't affect temperatures that huge amount compared to Vcore and input. 1.25 I/O and SA. The system agent, external system agent, is not used, so it's still quite weird that it exists with these CPUs, but I just leave it at that value, but you can leave it at auto because it's not used. The internal system agent offset is the memory controller voltage of the Skylake X and newer X CPUs on the X299 platform, and we will use a value of 400 on that. So let's use these values and let's save and exit. All the unnecessary things are disabled. Okay, so now we are in the operating system. It did boot fine. So let's see if we can pass Cinebench and see the temperatures. So because I am not like fully confident about the lapping process, because as we already saw, it's not perfect. It should be somewhat okay, but the contact is only at the center, so it's like a round object. The corners are not hitting the water block well at all, as we already know. So let's see the CPU Z. So yeah, 4.9, the Vcore is reading correctly on this on the X299 dark. Memory is correct, 34 on the mesh. So yeah, the mesh is already quite high. So if it crashes, we cannot be fully certain that which one caused the crash, core or the mesh. So let's see. What is this? World record. No damn idea why it's not running. Let's try 11.5. It's around the same. Well, it is around the same. Not enough memory. What is this? Yeah, I need to increase the max memory because I was using the mainstream platform with this. And on X299 you can use higher maximum memory in the operating system because it's 2 gigabytes per stick. On mainstream we have 2 sticks, that means 4. On X299 it means 4 times 2, so we can use maximum of 8. But usually I set like 6 to 7 gigs. And someone was asking that where do I set the max memory? So you just type in msconfig, so it means Microsoft configuration. Go to the boot tab, advanced, and maximum memory. We will type in. I will type in 7,000. But if you are on the mainstream platform, you need to type in 4 because it's 2 gigabytes per stick. Now I have 4 sticks of Samsung BDI in the system, so we can type in 8 or a maximum of 8. So, and now we are in the operating system again. Core temp. Funny, I have not seen that before. So yeah, if you run out of memory, it will give some weird error. Cinebench test, I mean. So it's not a world record, a valid one. So let's see, 4.9. Let's hope it passes. Fingers crossed. $73 or 72 to the lowest one was 69, so ranging from 69 to 85, 84, 85. So 16-degree variation between the actual cores. I have no reference point right now, but it's quite high. Room temperature at the moment is like 26 degrees Celsius, so not the coolest possible, but it already shows us that the maximum voltage we can use is 1.3 volts, definitely. So we cannot go higher than 1.3 for tests like this. Before we reset, because I cannot use the newest Elite, does not work for X299 Dark, apparently, or I already knew that. So I have to use an older version. The EVGA Elite X1 works for the mainstream plus the Z490. We will talk more about the Z490 Dark hopefully soon. I'm waiting for a new board. Currently it should be coming in very soon. But anyway, so for X299 Dark you should use a light version of older Elite version, and well, for Z390 Dark I've been using the no VMI dependency light version from December 5th of 2018. It works well, but doesn't have that much control compared to the Elite X1. But let's try, now that we passed, and it's a good result that we did pass, let's try Geekbench 3, because Geekbench 3 is a lot harder to pass for the vMesh and Cinebench R15. So now we have 3.4, 3400 MHz on the mesh at the moment, and it passed Cinebench R15, but can it pass Geekbench 3? So that we will see that now. So temps should be around the same in this test. The hardest part will be DFFT, temperature wise. That uses AVX instruction set, so we have to be careful with the temperatures when we run these tests with relatively high voltages and clocks. Dijkstra is the hardest part to pass memory wise, so if you can pass that, then you should be able to pass the whole test memory wise. But now, so SGEM, now we will see SFFT and then DFFT. So DFFT 89, 90. Second last core went to 90 degrees, so that's definitely hot. But yeah, we did pass, and very nice memory score of 10,311. So that means that we still have some headroom available on the mesh. But yeah, really hot CPU. So can't really go that much hotter. The previous chip I tested more during like winter time. It was in like March, April, February. So and in the winter, so I had a lot cooler room temperatures. I had like room temperatures of 19 to 20 degrees. So that's already much easier to bench in compared to this. So let's reboot and let's try. I will try 5G with the same voltage. So in the BIOS we just set the maximum ratio limit to 50 from 49. Now, by the way, on this board, if you have this set up in your case, like daily use, well, I have already said this many times before, definitely utilize the onboard debug LED monitoring feature. So go to the hardware monitor configuration in the advanced tab and 80 port mode configuration, and well, the main thing I would use this to monitor is the CPU VRM, because the VRM is definitely a question mark on the X299 boards, the 3647 boards and AMD Threadripper boards with CPUs that really draw a lot of power, and many of those onboard, like operating system programs aren't always that reliable to monitor the VRM temperature accurately. The onboard debug LED on the X299 Dark works amazingly well. It works better than on the mainstream platforms and on the SR3 Dark. So on this board it definitely works well. I have used it so many times, mainly to monitor the CPU die temperature. The CPU die temperature isn't that good for like air or water use. It's mainly for like liquid nitrogen purposes. So the thing I would measure is just the CPU VRM. So you can lock it to sensor 1 and select sensor 1 to CPU VRM. But definitely utilize it if you have this board and you have set it up in your case in like for normal use. But now let's try 5G at 1.24 Vcore. So now we are in the operating system again at 5G. If this passes, it's definitely awesome, but it's not certain at all. 5G at 1.24 volts is already quite high figure. It's about the same what I did with the 7900X, but the Cascade Lake CPUs, they are better on water on average compared to the earlier 7900 series Skylake X and the Skylake X Refresh. So let's open up Cinebench R15 again. Keep fingers crossed. Will it pass? Oh, so yeah. Already on the edge. So yeah, that definitely looks like that it's not going to pass. Well, it only needs to be better on cold compared to my earlier chip. My earlier CPU was amazing on water, and it still is, but it sucks on LN2. So only 5.7 on LN2. That's not a good result at all. So let's see how well this will do, but I will try to lap it more. So this is pretty much our max with this voltage. So now let's try. I will try the mesh, because that voltage I don't really want to go higher on water at all. and it usually doesn't even scale much higher than 1.35. So I just want to see what is the maximum of mesh first before we try to raise the core a little bit more. The core should do 5G when we increase the Vcore, but I'm sure it will not do 5.1 on water, based on the result we already saw now. Now water performance isn't everything, because my better 990 XC did only like 4.9, something like that, a touch over 4.9 in Cinebench R15 on water, but it did quite well on LN2, so like 5.85, something like this. So it's all about the scaling when talking about like cold use. Of course, just for daily use, the best possible voltage requirement on water is most important. But when it comes to this particular CPU, it only has to do well on LN2 for my use, because I already have really nice water 18 core, the previous 10980 XC. It's awesome. 5.1 R15 on water, something like that. That's absolutely amazing result. And yeah, it hang. So 35 is the limit, around 34 and 35, but that's quite normal for these CPUs. So now let's just move it back to 34 and try to increase the vehicle a little bit to get the 5 GHz to pass. One thing we can try is to lower the input voltage. Some CPUs like relatively low, at least on water, like 1.8. Usually 1.7 is too low, but generally too high doesn't help on water. Like 2.1 is the absolute max. Absolute max you should even try on water. Usually I just leave it at like 1.9, but we can try like 1.8 if this doesn't run stable. Yay, it passed, but it's very on the edge, as you already saw. So 91, 94, 93, 91, 91, 94, 93, 94. So yeah, we cannot go any higher on the vehicle. Now I will try to set the input a bit lower, so like 1.8. See if it helps a little bit. It should help the temperatures a few degrees, but most of the heat comes from the actual Vcore and the actual core speed. When you increase the core speed, the amount of current that the CPU draws goes up a little bit. So if we set a core clock of 800 MHz on both the core and the mesh, and if we use the same voltages, the max temp would be dramatically lower because of the difference in the actual core speed. So it's not only about the voltage, the core speed affects as well. And on this particular platform, the core speed really it really affects a lot. I mean the temperatures. So just take a quick screenshot. Now one thing of note about the input voltage is that if you set the input too low, it will affect your efficiency and performance, like visibly. So you will see that the scores are weird low for the given clock speeds and so on. That means that the input is too low. It's not like having the adequate performance compared to the clock speeds which they should give. So just saying that now we got 5050 in Cinebench R15 with the previous voltages. If it's now dramatically lower, like 4850, something like that, then we know that the input is too low for 5 GHz CPU speed. So let's see. Core temp is now open. Same Vcore, just input at 1.8, but I think it will crash very quickly. So yeah, doesn't seem to be more stable. Almost. I think it might pass on second attempt, but temperatures are roughly the same. So now we should be getting, not sure, maybe not a blue screen. So let's try. Well, temperatures are roughly the same, but I would like to see the score. Let's try this way. So at real time, it goes like half, a bit over half of the test, then it crashes. Now, based on this, we could try to increase the input a little bit, like 2 volts and a bit lower Vcore. So let's try that. But based on this, it's not more stable with this input voltage so far. Okay, so last attempt, 2 volts set on the input voltage and 1.27 on the Vcore. But I pretty sure it doesn't change at all compared to 1.9 input and 1.29 on the Vcore. So I'm betting it's like almost immediate crash in this test. So yeah, definitely worse. Really easy to see. So definitely worse. But I can double check this just to be sure. So not much difference there. Yeah. But the max temperatures seem a bit cooler, so that already shows that the most heat is coming from the actual Vcore, not from the input voltage. So and now it crashed. Okay, so this is definitely the last attempt. So 2.1 on the input, same Vcore, so 1.27. So yeah, doesn't really matter that much. The funny thing is about these CPUs is that they are nearly the same. So there's not that much difference between the actual chips, in my opinion, compared to the mainstream platform. So they really max out quite the same. If you have very good water cooling, every CPU, at least for me, has done at least 4.8. So usually like 4.9 to 5G is the max on water for tests like Cinebench. Of course, Cinebench isn't the test you want to use for determining your daily stability, even for like non-AVX situations. You should use Prime 95 without AVX and have lower clock for AVX programs. And yeah, so we crashed. But yeah, so now let's check how the IHS contact looks like, and then we can pretty much conclude this video. Okay, so that's actually that's not that bad, to be honest. The thermal base spread, except apart from the top part of the IHS, has been really good. Like no spider web or similar. So I think it's quite good. I should do a dry mount test with a liquid nitrogen container first, before going any further with lapping. Because this way of mounting, using these long LN2 rods, isn't the most ideal way to mount. The overall mounting pressure isn't even between each of the rods. So we can see from this that the bottom side has had more mounting pressure than the top side. So best to try with liquid nitrogen pot first, see how it looks like after a dry mount, and then do some possible, do more possible lapping. But overall, that's pretty much the conclusion of this chip. Pretty much the same as the other CPUs I've had. Worse than the previous 10980XC, like 100 MHz lower, but likely better on LN2. The previous one, 5.1 Cinebench or water, but very bad on LN2. Like the 9980XC was 4.9 plus max, on LN2 like 4.94 if I remember correctly, but 5.85 on LN2 versus the 5.7 on the 10980XC. So scaling is what matters, but 5G is already a good result, and could probably do like 5 GHz stable if I had a better mount, like constant looping at 5G, but definitely not 5.1 on this chip. But yeah, if you like to see this new CPU on water, like basic tests and how I win these, then leave a thumbs up and subscribe to my channel. But other than that, thanks for watching one of my videos once again, and see you on the next one.